All right, so starting for this worksheet, it says for each polar function, determine whether r is increasing or decreasing across the given interval. So remember, we just do this by making a table of values, and we look at whether the numbers are increasing or decreasing. So, and sometimes it could be increasing for a bit and then decreasing. So when I do this, because we're not really sketching graphs, it's a good idea to plug in all of the nice common angles that you have in case there is a place where the graph changes from increasing to decreasing or vice versa. So I'm going to plug in all of the common angles, including these endpoints. So we're plugging into r equals 1 plus 2 cosine theta. So we're going to start with 0, but then we're also going to plug in all three common angles and pi over 2 at the top. So when we plug in 0, we get 1 plus 2 times cosine of 0 is 1. So that's 3. Then we plug in pi over 6. 1 plus 2 times radical 3 over 2 is 1 plus radical 3. Now remember, radical 3 is like 1 point something. So we're going from 3 to 2 point something if we add 1 to that. So decreasing so far. And then pi over 4. 1 plus 2 times radical 2 over 2 is equal to 1 plus radical 2, so a little bit less. Pi over 3. 1 plus 2 times 1 half. 1 plus 1 is 2. So we went from 3 to 2 point something to 2 point something smaller to 2. Pi over 2 is 1 plus 2 times 0. So down to 1. And then finally 2 pi over 3. 1 plus 2 times the cosine of 2 pi over 3 is negative 1 half because you're in quadrant 2. So 1 minus 1, 0. So what are these r values doing? R is decreasing on 0 to 2 pi over 3. So again, could I have gotten that by just plugging in 0 and pi over 2 and 2 pi over 3? Yes, but you don't want to miss any angles because just in case the graph changes from increasing to decreasing somewhere along the way. If we don't see that today, we will see it tomorrow. We want to be sure we're ready for that. So just be thorough about plugging these in. And now we're going to go from 2 pi over 3 to pi. So I'm going to plot all three of these quadrant 2 angles plus pi. So you already did 2 pi over 3, but it's worth writing down again because you are comparing what's happening after that. So when we plug in 2 pi over 3, we take a look at what we got here. We got 0, so no need to recalculate. And then the next angle will be 3 pi over 4. 1 plus 2 times negative radical 2 over 2. So you are expected to be able to compare, look at this difference and see if it's positive or negative without a calculator. So again, radical 2 is 1 point something. So 1 minus 1 point something is something negative. So we're going from 0 to a negative. And then when we plug in 5 pi over 6, we're going to get 1 plus 2 times negative radical 3 over 2. 1 minus radical 3 is a little bit more negative, right? And then when we plug in pi, 1 plus 2 times negative 1 is equal to 1 minus 2, so negative 1. Now, even though the absolute value of our numbers is going up, so 0, negative 0 point something, negative 0 point something, negative 1. Remember, with negative numbers, this is still r is decreasing. And the more negative you get, you're still decreasing. So negative 1 is smaller than 0. So r is decreasing on 2 pi over 3 to pi. Even though we're plugging in those endpoints, we're keeping parentheses with these just because to keep it matching the interval that we're given. And then for this last part, we're going from pi to 5 pi over 3. So we're going to plug in all three of these angles plus 3 pi over 2. Right, so we're jumping off from pi here. So when we plugged in pi, we got negative 1. And then we're going to plug in 7 pi over 6. 1 plus 2 times, cosine's still negative down here, so negative radical 3 over 2. So this is 1 minus radical 3. So we're kind of climbing back up, right? So 1 minus radical 3 is a little bit bigger because it's closer to 0 than negative 1. So we're getting a little bit bigger. We're increasing. And then we're going to put in 5 pi over 4. 1 plus 2 times negative radical 2 over 2. 1 minus radical 2, a little bit closer to 0, so a little bit bigger than that number. And then 4 pi over 3 is 1 plus 2 times negative 1/2. So 1 minus 1 is 0. That's the biggest number of all so far. It's the only non-negative. And then we're going to 3 pi over 2. 1 plus 2 times 0 is 1, so now we're in the positives. And finally, 5 pi over 3. Now in quadrant 4, cosine is positive, so positive 1/2. So 1 plus 1 is 2. So on this entire interval, we're increasing as well. We go from negative 1 to negative but closer to 0, negative but a little bit closer to 0, 0, 1, and 2. So on this entire interval, r is increasing 1 pi to 5 pi over 3. The other reason I'm being thorough is because if we have to do this for the AP exam, I'm not sure how much work they're going to require that we show. So good to look at this. All right. Using this polar function from number 1, so same problem, determine whether the polar graph is getting closer to the origin or further from the origin. I think it's farther. I mess this up all the time. Or farther from the origin. So, all right. So if we're looking at this, closer to the origin, we had this in our notes, right? When are you getting closer to 0? When these signs are opposite. I kind of think of it as like I'm going forward, but I'm putting on the brakes, so I'm slowing down to 0. Versus getting farther from the origin, I'm driving fast away because I'm accelerating in the same direction I'm going. So the signs are the same. This is a concept we revisit in calculus when we compare velocity, acceleration, and whether the speed is increasing or not. So a little preview here. Okay, so what do? We are using the problem from number 1 because you need to know 2 things. Justify your answer using the value and behavior of r at this specified point. So what is r of pi over 3? Take a look at your table. You don't have to recalculate. We did this in part A. R of pi over 3 is equal to 2. 2 is greater than 0. So r of pi over 3 is positive, greater than 0. And what's the behavior of r on this entire interval? So at pi over 3, we're on this interval. R is decreasing at pi over 3. So when I say that the signs are opposite or the signs match, r is positive, that sign is positive. And then decreasing in my brain, I'm thinking a sign of negative. I'm not saying r is negative or anything. I'm just thinking about these 2 directions. So these are opposites. So therefore, these 3 little dots in math, for some reason, it's a symbol for therefore. Therefore, signs are opposite. So the curve is getting closer to 0, 0. If we were to graph 1 plus 2 cosine x, whatever kind of curve that is, whether it's a cardioid or I forget the rules, whether it's a cardioid or a loop or whatever, at pi over 3, we should find that our radius is getting closer to the origin. So same idea here. At 5 pi over 6, first show, because remember we have to justify. So show what r of 5 pi over 6 is. So from this problem, it was 1 minus radical 3. Make a statement about whether that's positive or negative. So r of 5 pi over 6, 1 minus 1 point something is negative. So r of 5 pi over 6 is less than 0. And what is r doing? R is decreasing at our angle, 5 pi over 6. You could also say on the interval this, but I just like to say at that angle. So negative and negative, decreasing, I think negative, actual negative value is negative. Those signs are the same. So that means that the curve is getting, I think it's farther. Sorry to all my English people here. Farther from 0, 0. I even checked with Mrs. Trujillo one year, like is it further or farther? And she told me, and I forgot. So anyway, okay, so 3 pi over 2, r of 3 pi over 2, what was that equal to? Checking my table up here, that's equal to 1. That means that r of 3 pi over 2 is positive, greater than 0. And what's the behavior of r? R is increasing at 3 pi over 2. So positive, increasing, I think of that as positive. These two signs are the same conclusion as last time. Curve is farther. I should say getting, I just ran out of room, from 0, 0. So again, if you're in physics, think of this as like we're pairing up a negative velocity with a negative acceleration that should shoot us further in the negative direction. A positive velocity and a positive acceleration, we're shooting farther in the positive directions. We're getting farther in both cases. But if we had a positive velocity and a negative acceleration, they'd be acting against each other and you'd be slowing down. And so we're getting closer to 0. So that's how I can remember that. You don't have to be in physics to make sense of that, but you can kind of apply that same idea. All right, so here's another polar function. This is one of those rose curves. Determine whether r is increasing or decreasing across the interval. Again, just make a table of values. So we're going to use the interval that was given. We're plugging into r equals 6 sine of 2 theta. And I like a little sketch over here just to show myself a nicer visual of what angles I should be plugging in between. So there aren't as many on here. We're going to plug in 0. 6 times the sine of 2 times 0 is equal to 0. And then we're going to plug in pi over 6. Make sure you're plugging it into 2 theta, though. So when you plug in pi over 6, you get 6 times the sine of 2 pi over 6, which is really pi over 3. That's 6 times radical 3 over 2. So 3 radical 3. So far, the number has gone from 0 to a positive, so r is increasing. And then pi over 4 will be 6 sine of 2 pi over 4, because it says 2 theta, so that's pi over 2. 6 times 1 is 6. So on this interval, r is increasing on 0 to pi over 4. Okay, for our next part, now we're looking at pi over 4 to pi over 2. So there's only one common angle between there, pi over 3. All right, so we already found pi over 4 from our last problem. That was 6. Let's plug in pi over 3. So then you get 6 sine of 2 pi over 3, because it's 2 theta. Now sine in quadrant 2 is still positive, so this is 6 times radical 3 over 2, which is 3 radical 3 again. And then plug in pi over 2, but that's 6 times the sine of 2 pi over 2, sine of pi. Sine of pi is 0. So 6 to 3 radical 3 to 0, that means r is decreasing on pi over 4 to pi over 2. All right, this section here, 7 pi over 6 to 3 pi over 2. So there's the pi over 4 and the pi over 3 angle to plug in there. So theta is going into r equals 6 sine of 2 theta. Start at 7 pi over 6. Now I didn't plug that in from the previous section, so I have to do the math. That's 6 times the sine of 2 times 7 pi over 6, so 2 over 6. 7 pi over 3. Now this is bigger than a full circle. 7 pi over 3, think of that as a mixed number. 2 pi would be 6 pi over 3, so that's 2 and 1/3 pi. In other words, that's 2 pi plus 1/3 pi, or pi over 3, so you land right here. That's the same as 6 times the sine of pi over 3. So 6 times radical 3 over 2 is radical 3, or 3 radical 3. All right, and then plug in 5 pi over 4, 6 times the sine of, so it's going to be 2 times 5 pi over 4, so that's 5 pi over 2. 5 pi over 2, again, this is like 2 pi is like 4 pi over 2, so 5 pi over 2 lands up here. So that's really the same as sine of 5 pi, of pi over 2. So this is 6 times 1 is 6. So far we're increasing. And then we're going to put in 4 pi over 3. That's 6 times the sine of 8 pi over 3, since it's 2 theta. What about 8 pi over 3? That is 2 and 2/3 pi. So that's 2 full pi plus an extra 2/3. That lands you in quadrant 2. That's 6 times positive radical 3 over 2 again. 3 radical 3. And finally, we get down to 3 pi over 2. So that's 6 times the sine of 2 times 3 pi over 2 is 3 pi. Back to 0. All right, so what's happening on this interval? So increasing from 3 radical 3 to 6, but then from 6 to 3 radical 3 again, you're decreasing and decreasing again to 0. So r is increasing from 7 pi over 6 to 5 pi over 4, and r is decreasing from pick back up at 5 pi over 4 to 3 pi over 2. Looking at when things are increasing or decreasing is huge in calculus, whether you're in AB or BC. So you will hopefully get used to doing this, and we can do this by little charts or number lines or whatever. All right, and then let's do the same thing we did in problem 1. So using the polar function from number 2, determine whether the polar graph is getting closer. Remember, that means sines, put signs in quotes, I guess, are opposite. So the value of r is a different sign than whether r is increasing or decreasing. Or farther from should be the signs are the same. They're working together to get you far and away from 0, 0. Okay. So we do this by justify your answer by using the value of r, meaning the value of r at that angle, or what is r of pi over 12, which I didn't find over here, right? I didn't plug that in, so I'll have to plug that in. And then the behavior of r at that point. So pi over 12 does fall between 0 and pi over 4. And maybe you put pi over 12 in here, I don't know, but I did not. So 6 times the sine of 2 pi over 12 is pi over 6. So that's 6 times 1/2. So that's 3. So the important part is that r of pi over 12 is greater than 0. And because pi over 12 is on this interval, I can say r is increasing at pi over 12. So you don't have to show the positives for the AP test, but this is, I'm thinking in my head, positive, increasing in my head connects to positive. Those two signs match. So the graph or the curve or whatever, R, is getting farther from 0, 0. Okay, what about a pi over 3? So pi over 3 I did plug in here. So r of pi over 3, when I plugged that in, I got 0. So now, if I got 0, that's not positive or negative. That's equal to 0. So what's happening there? Well, if I plug in, oh no, wait, sorry, I didn't get 0. Somehow this got shifted around. What I was going to have to do was, if I got 0, I was going to have to pick the angle on either side and see, like, does it go up from there or down or what? But okay. So r of pi over 3 is not equal to 0. It's equal to 3 radical 3. And r of pi over 3, that means that that's greater than 0, so positive. And on this interval, pi over 3 is on this interval, so r is decreasing at pi over 3. So positive r value, but negative behavior, I should say, like direction, decreasing. So therefore, the graph or the curve or R, whatever, is getting closer to 0, 0. Again, I think of getting closer to 0, 0 as like slowing down. You're going forward, but you're hitting the brakes, versus going forward and hitting the acceleration. All right. 5 pi over 4. So R of 5 pi over 4, again, somehow this got scooched a little bit, but that equated to this. So R of 5 pi over 4 is 6. Now here's one where this is kind of what I was about to run into with 0. When we get 6, that's where the graph changed from decreasing to increasing. So on this interval, R is not always increasing or always decreasing, and 5 pi over 4 is the turning point. So this is there should be a third option that says, are you getting closer, or are you getting farther from the origin, or neither? So this graph is neither closer nor farther from 0, 0. It's really because the graph goes from increasing to decreasing. We're going to talk about this more tomorrow, but that's where there's a relative maximum. So graph is neither closer nor farther from 0, 0 because let's say R changes behavior at 5 pi over 4. Tomorrow we're going to get more into like, well, what about that? It's changing from increasing to decreasing. So R, I would say R is a relative maximum at 5 pi over 4. So if it's one of those extrema, you're not getting closer or farther, you're in one of those turning points. Right? What if we're given a table? So use the table to determine whether the polar graph is getting closer to the origin, farther from the origin, or neither at the specified angle. Justify your answer using the sign and behavior of R. So this just has done some of the work for us. Let's first take note of what's happening. From 1 to 0 is a decrease. From 0 to a negative is a decrease. From a negative to more negative is a decrease. And this is like negative 0 point something, and this is negative 0 point something, negative 1. And then 1 minus 1 point something is back to negative 0 point something. So this graph from 0 all the way to pi over 2, it looks like R is decreasing. But then pick up at pi over 2 out to 2 pi over 3, it looks like R is increasing. So what's happening at pi over 4? So R of pi over 4, I'm doing the same thing I did in that last problem. Report the value. It's 1 minus radical 2. Report what that means about the sign of R. R of pi over 4 then is negative, so less than 0. And what is R doing at pi over 4? This is in the decreasing section. So R is decreasing at pi over 4. So what can we conclude? A negative R coupled with a negative direction. Those two signs agree, so we're getting farther from 0. So the graph or the curve is getting farther from 0, 0. It's like we're accelerating in the negative direction. What about at pi over 2? So pi over 2 is our turning point, right? R of pi over 2 is equal to negative 1. But can you classify pi over 2 as increasing or decreasing? No, it's where the graph switches from decreasing to increasing. So it's actually a relative minimum. So I would say curve is neither closer or farther from 0, 0 because R changes from decreasing to increasing. Or what did I say last time? Changes behavior. There are a few ways to say that, although again in calculus we like to specify decreasing to increasing or vice versa. All right, and what about 2 pi over 3? So R of 2 pi over 3 is equal to 1 minus radical 3, which is negative. And if I really want to be thorough about this, I might plug in one more angle and say, well, what about what's happening at the next angle over at 3 pi over 4? I'd get back to 1 minus radical 2. So it's like a negative 1 point or negative 0 point something closer to 0. So r is still increasing past 2 pi over 3 when you plug that in. So I would say, I mean, you might not have actually had to extend that out, but if we're plugging in an endpoint of an interval, it's hard to know, like, well, does it keep increasing or not? You kind of have to check the angle next to it. So r is negative and r is increasing at 2 pi over 3. So negative but positive sort of connection there. So that means that the graph is getting closer to 0, 0. Justify, gosh, because, or no, I already justified with my work. What am I saying? All right, so one more of these. These are nice numbers. It's much easier to see whether we're increasing or decreasing. So going from 4, 2 to 0, definitely a decrease. We continue decreasing into the negatives. So up to pi over 2, r is decreasing again. And then after pi over 2, you start increasing again. All right, so r of pi over 3 is equal to negative 2. That is definitely less than 0. And r is decreasing. So a negative and a negative, r is decreasing at pi over 3, I should say, mean they're acting together. So we're getting farther. I'm getting kind of lazy here, but farther from 0, 0 at that point. What about 5 pi over 6? R of 5 pi over 6 is equal to 2, which is definitely greater than 0. And r is increasing at 5 pi over 6. So this is positive. Increasing, I think of that as positive. And so that means that our signs agree. So again, here we're getting farther from 0, 0. Final spot here. R of pi over 2 is equal to negative 4. But negative 4 is where we change from decreasing to increasing. It doesn't fall into one or the other category. So, but R changes from decreasing to increasing. So therefore, neither. All right. I would prefer for you to write these out nicer, like I did in the beginning of the worksheet, as far as answering this for your AP exam. But we'll get there when we practice more. All right, that's it for this worksheet. Come on into office hours if you need practice.